In 8.1, we started talking about graphing, but in 8.2, we're going to be a little bit more specific about it. We're going to look at functions, and we're going to find the zeros first. So first, find the zeros. And then secondly, after we find the zeros, we're going to pick values between the zeros and outside the zeros. And the reason we're doing this is so that that way we can get a more accurate representation of what the graph actually looks like. Before, if you remember in 8.1, what I was doing is I was saying, well, you know, there's a zero, there's a zero, there's a zero. The end behavior is up, and oh, maybe it does this. Okay, but what we want to do by picking values between is say, well, instead of just guessing at what happens here, well, if I pick a value in between these and it lands here, and I pick a value between these and it lands here or wherever, then now I have a more clear picture of what happens. Instead of me guessing, now I have a very clear picture of what's happening. And the more points you put on this, the more clear that picture becomes. And when I say pick points outside, if I pick a point outside this and I say, well, the point's here and the point is here, then not only do I know how it's going between the zeros, but also how it's going to go on the outside as well. Graphing, except this time it's already factored, and it's fourth power because there's 1 here, 2 here, and 1 here, so that's total of 4. And it's also positive because there's no negative in the front, and so we know that our graph in the long run will look something like this. Okay, so what I want to do now is first I have to find the zeros. So x equals -1, because setting that to 0 gives me -1, setting this to 0 gives me 2, and lastly I have 4. Okay, so what I want to do is I want to plot these real quick. -1, 1, 2, 3, 4. So we have -1, -2, +2 and +4. Okay, now we know the end goes up on both ends. And so what we're going to do though is we're going to look for more specific values. So what I want to do is I want to choose a value between -1 and 2. Well, the easiest value to choose would be 0, right? So if I put 0 in here, I get 0 plus 1 times 0 minus 2 squared, 0 minus 4. Okay, well that's 1 times 4, right? -2 squared is 4 times -4. Well, what's 4 times -4? That's just -16. So we get 0, -16. So that means I need to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, all the way down to 16. Okay? Now, let me pick a value between 2 and 4. That one also seems pretty easy. How about 3? So let me plug 3 in. 3 plus 1, 3 minus 2, 3 minus 4, but I forgot the square. So that's 4. 4 times, what is this? 1 squared is 1. 3 minus 4 is -1. So 4 times 1 times -1 is -4. And so we get 3, -4. So 3, 1, 2, 3, 4 is down here. Okay, so we know that the end goes up, it comes down to here, and this point here is something different because this is square, we know it bounces. So we know that the point does this. Bounces because it's 2. Power of 2 or 4 or 6, any even power at a root will bounce. Odd powers will go through, and if it's more than 1 and it's odd, it will curve. Now, these are both 1, so we know that these just go through. But before I put the two end pieces on, I want to pick a value to the left of -1 and to the right of 4. So if I pick something to the left of -1, how about -2? So -2 plus 1, -2 minus 2 squared, -2 minus 4. Okay, so -2 plus 1 is -1. That's -4 squared is 16. Ugh, and that would be -6. So this is a pretty big number. We have 6, because this is negative, they go away. So 6 times 16 is, let's see, 6 times 6 is 6, carry a 3, 96. Nope, 80. No, I was right, sorry. 96. Okay, so that means 296. Way up here. Okay, now, how about 5? We plug 5 in, what do we get? 5 plus 1, 5 minus 2 squared. Sorry, 5 minus 2 squared, 5 minus 4. So that's 6. 3 squared is 9. So 5 minus 2 is 3 squared is 9. And 5 minus 4 is 1. And so we have 72. So 5 comma 72. So 5 comma 72. And so our function should look something along those lines like that. One last thing that I want to mention before we kind of wrap this up is this idea called the intermediate value theorem. This theorem's idea is that if I pick a value on my graph, on my function, and I pick a second value on that same function, if the signs have changed, then there's a real zero between them. So let's look at what that means graphically, just to kind of get an idea. If I pick a point here and a second point here, the sign of this first point is positive. The sign of this second point is negative. Why? Because the first one is above the x-axis. The second one is below the x-axis. So this is a positive value. This is a negative value. What that tells me is if these two values have opposite signs, it must cross the x-axis. It's got to have a 0. And if, for example, they were both positive, like this, so this one's positive, this one's positive, it doesn't cross because both of these values are positive. Now, there are cases where you may have picked numbers that are too far apart, and you may need to pick numbers that are closer together. So let me show you a case like that. But before, I'll do an opposite one. What if it starts off negative and ends up positive? It crosses. So anytime that you have this, where the signs change, it must have crossed the x-axis. It has to have crossed the x-axis. Now, if the signs are the same, it does not mean that it didn't cross. It just means that you don't know that it crossed. And here's an example of what I mean. If I have a function that looks like this, and I have a point that I picked here, and my function does this, and I have a point, this one's positive, this one's positive. But because I picked values that are too far apart, I missed this information. Okay, I missed that information. So I would look at this and I would say, oh, it doesn't have any zeros between these 2 points. But if I divided that in half and I picked a halfway point, then I would say, oh no, I missed a lot of data because this is actually positive, negative, positive. So you do have to be careful with this intermediate value theorem, okay? The only thing it tells us is if it's positive and negative, there's a 0 between them. It does not tell us that if they're both the same, there is not a 0, as we saw in this example.